So let's say we're asked to find the equation of a line given a particular point. How about -2, 7 and a particular slope. So slope is, let's make it interesting. Let's go with maybe 3/4. So this is going to end up, I think we're going to have some fractions to deal with, but we'll cross that bridge when we come to it. Okay, so we could very easily graph this line. Let's plot that point, -2, 7. 1, 2, 3, 4, 5, 6, 7. So here. And if I want to plot another point, I can go up 3, right 4. I'm going to be right on the edge. So up 3, 1, 2, 3, 4. Or I could go down 3, left 4. 1, 2, 3, 4. And that gives me a little bit more space to work with. So here's that line, and we want to find its equation. And typically, not always, but typically we're going to be asked to write our answer in slope-intercept form, which is the y equals mx plus b form. And we've got the m, so we're quite a ways towards finding our final answer. We just need the b. And the b, we can at least like estimate it from this graph that we drew. It looks like it's going to be like 8.5 or something, but it's kind of hard to tell. So let's see how we would do it if we didn't have the graph to look at. Well, we do have a point, and this is an xy pair on our line. So let's try putting in x equals -2 and y equals 7 into this kind of partial equation that we've got. So y is 7. Then we have 3/4, x is -2, and now we have plus b. So now we have an equation that's all numbers except for the b, so we can solve for b. So this is one way to do this. There's other ways, but let's go ahead and finish it, and I'll show you another way. So let's see, 4 and -2 cancels. We'll have a 2 left here, -1, so we'll have 7 equals -3/2 plus b, and then add 3/2 to both sides. We often are asked to leave things as fractions, so I'm going to just go with the fractions. 7, if I get a common denominator, 7/1 would be 14/2. So 14/2 instead of 7. So 14 plus 3 would be 17. So 17/2 is our b. So final answer, y equals 3/4 x plus 17/2. If your program is okay with a decimal, then what would that be? 8.5? 8.5. Oh yeah, and that's what we thought it might be. That was the estimate from looking at the graph. Okay, let me show you one other way that we could figure this out. And this is using another form of a line. So we've talked about slope-intercept, y equals mx plus b. This is the slope-intercept. Another form is if you know a point, but it's not the intercept. It's not the y-intercept. It's some other point. Let's call it x1, y1. And you know the slope. Then the equation, or you can kind of start out with y minus y1 equals m times x minus x1. And this is really the slope formula. So remember the slope formula between 2 points. This is all getting kind of busy. If you have 2 points on a line, x1, y1, x2, y2, then the slope is difference in the y's, y2 minus y1 over x2 minus x1. If I just multiply both sides by that denominator, m times x2 minus x1 equals y2 minus y1, and then kind of flip it around and erase the 2's, I've got this other form of the equation of a line. So if that didn't make a whole lot of sense, it's not a big deal. What I'm trying to explain is that this form really is just the slope formula rearranged. And this has a name. It's called the point slope form. So point for the x1, y1, any random point on the line, and then of course m is the slope. So if we want to apply this, and here, let me get rid of all of this stuff. So apply this to this particular problem that we were looking at. So our point was -2, 7, and the slope was 3/4. So let me go back here. Our point was -2, 7, m, slope was 3/4. So if we go use this point slope form, our y1 is 7. So this is, of course, x1, y1. So we're going to have y minus 7 equals, and then m 3/4, parentheses, x minus x1. So x minus -2. Be careful with the negatives. You'll have a double negative. So this actually is the equation. If the directions didn't specify the form, then you could just leave it like this. But if it specifies that it wants slope-intercept, that means we basically have to clean it up and solve for y. So to clean it up, we can get rid of that double negative. We've got this 3/4, and then x plus 2. So then we can distribute the 3/4. Come over here, y minus 7, 3/4 x. And then plus, so 2 and 4 will cancel. We'll have 3/2. Add 7 to both sides. We'll end up doing the same calculation that we did earlier to get the 3/2 plus 7 to get a common denominator, blah, blah, blah. And we're going to end up with the same thing. Y equals 3/4 x plus 17/2. So whichever method is more familiar, comfortable, whatever is the method you should use. It doesn't really make a whole lot of difference.